Now let's discuss the velocity of an object thrown at an angle. Now here, let's look at the object. This is our ball. The initial velocity that we give it is going to be the blue arrow here. And the simulation is allowing us to see the horizontal part of that velocity, or the horizontal component, which is in red, and the vertical component, which is in black. Now, as we have discussed earlier, we have an acceleration only along the vertical. What that means is, and that acceleration is downwards, opposite in direction to the velocity. What that means is, this vertical component of the velocity is going to diminish because of that acceleration. And that's what we see. It gets smaller. Now, along the horizontal, we don't have an acceleration. That results in the horizontal velocity remaining the same. Once we reach the topmost position, the vertical velocity becomes 0. But the horizontal velocity never changed. Let's go back for a second here. Overall velocity is the blue one. It has two components, red and black. But it has an acceleration. It is subject to an acceleration only along the vertical, along the direction of the black arrow. So only the black arrow is going to diminish from here to here. But as the black arrow diminishes, the overall velocity diminishes as well, because it's made up of both. And one of the components is smaller, so the overall velocity is smaller. At the topmost position, we don't have any vertical component of the velocity anymore. So that's the minimum value that my velocity is going to get in this path, meaning it has no more vertical component, it has only a horizontal component. So my blue vector is going to be pointing along the horizontal, and it's going to be equal to the red vector that's not shown here. Okay. What's going to happen after that topmost position? We still have the acceleration along the vertical, which means that our ball is going to continue to accelerate along the vertical. 0 velocity acceleration downwards, meaning it will speed up in the downward direction. So we have a higher velocity along the vertical and an even higher velocity along the vertical. Again, still, the horizontal component of the velocity is going to remain unchanged since we don't have an acceleration along the horizontal. Okay, we can view that here. Okay, so reset, play. You notice there, that's what happens. Vertical component diminishes and then increases in the opposite direction. Horizontal component never changes. Topmost position, the only velocity remaining is the horizontal velocity. So the overall velocity is equal to the horizontal velocity. The vertical velocity is 0. That's the small vertical velocity. Now a small vertical velocity in the opposite direction.